Hello everyone, this is Aditya and today we have to solve this physics problem, so let's see how we'll solve it. But for that, please do like, share, subscribe my channel and please support video. Now let's start. So first of all, let's understand the question. So question states two balls having masses m and 2m. So m and 2m are fastened to two light strings of same length L. So basically this is the hinge and this is the length L and this is the length L. So these are the two strings, right? And we have held the balls like this using our hand. Okay, so this is the case. The strings are kept on same horizontal line. Okay, so they are on the same horizontal line, okay, or same horizontal level. Okay, and the system is released from rest. The collision between the balls is elastic. Okay, so of course if the ball is released like this, so of course they will collide with each other because they have the same length, because the length of string is same, so of course they're going to collide. Okay, so we find the velocity of ball just after collision and how high the balls will rise after collision. Okay, let's see how we'll solve it. So to understand this, to find the velocity after collision, we should know the velocity before collision and then we can apply law of conservation of linear momentum along x-axis, so we can easily find the final velocities. Okay, so let's assume that this is the x-axis and this is the y-axis and this is the positive and this is the positive side. This I will use for convention and this I will use as negative convention. This will be negative convention. Okay, so far so good. So of course if we take this case, so when this mass m will come over here like this, wait a minute, somewhat like this. So what will be its velocity? It will be, suppose, u1. Okay, and when this mass, I am drawing it separately so that you can understand it better. Okay, so this is this 2m mass, and when it will come like this, it will be over here, it will be going with velocity u2. Okay, fine. Okay, so this is also going to come like this. Okay, so how we can find the velocity u1 and u2? Well, this is the length L. How much height the ball has descended? Well, the length L, right? Hence, by work energy theorem, we can say that the work done by gravity, that is force times the displacement, since the displacement is along the force is also downward, and the length is also, the displacement is also downward. Okay, so mgl is equal to the change in kinetic energy. What is it? Half m into u1 square. So we can say that, why I have taken the change in kinetic energy as half mu1 square, why I haven't considered initial kinetic energy? Because we are given that the ball is released. So what does release mean? Well, it is released, basically the initial velocity is 0, so it is just we have dropped it, right, like that. Okay, hence the initial velocity is 0, so initial kinetic energy is also 0, so we won't consider it. Okay, hence u1 is equal to root 2 gl, correct? Okay, now for this case, again 2 mgl is equal to half into 2m into u2 square, correct? Okay, so over here also we'll get u2 is equal to root 2gl, right? Fine. Okay, so it means that u1 is equal to u2, but there's one problem. u1 is along the positive side and u2 is along negative side, hence this is actually negative. Okay, correct. So I won't draw it like this. So basically they are going to collide. So of course this is something like this. This is u1 and this is u2. Okay, like this. Okay, so I've drawn it separately. Okay, so let me erase this, and yeah, so we have got the velocities, and now we are going to draw the velocity after collision. So suppose after collision it has the velocity v2 and it has the velocity v1. Okay, let's assume it. Okay, so what will be the initial momentum? Well, initial momentum will be equal to m times u1 plus 2mu2, correct? This will be the momentum, linear momentum along x-axis. We have to conserve the linear momentum along x-axis because there is no external force acting along x-axis. We know that F external is equal to dp by dt, right? So if F external is 0, so p is equal to constant, hence linear momentum along that direction will be conserved. Okay, so along x-axis there is no force, right? Hence there is no external force, so that is why. So it is equal to m times u, that is what is the u, what is u1? u1 is equal to root 2 gl minus 2m root 2 gl, so it is equal to negative m root 2 gl, right? So this is the initial momentum of the system, and what is the final momentum? Well, let's see that also. So the final momentum will be equal to P final, it is equal to mv1 plus 2mv2, right? Correct. Okay, so these two must be equal, right? So by law of conservation of linear momentum, we can say Pi is equal to Pf. Hence, we have negative m root 2gl is equal to the quantity m times v1 plus 2v2, right? Okay. So from this, we can say that v1 plus 2v2 is equal to quantity negative root 2gl, right? So far, so good. Now, what we have to find? We have to find the velocity. But how we'll find it? Because we have just one equation. Well, just see in the question, it is given that the collision between balls is elastic. So we all know that elastic, that is the coefficient of restitution, that is E, is equal to the velocity of separation divided by velocity of approach, right? So it means that V2 minus V1 divided by the quantity U1 minus U2, correct? U1, this is U2, and this is V1, this is V2, this is V2, correct? Okay. Hence, 1 is equal to V2 minus V1 divided by root 2 GL minus root 2 GL, right? Remember, U2 was equal to, I will erase that, but U2 was equal to negative root 2 GL because it was in the negative direction, okay? So we have V2 minus V1 is equal to 2 root 2 GL, right? So we have this expression and we have this expression, so we can just solve it. So we have V2 minus V1 is equal to 2 root 2 GL, and we have the quantity 2v2 plus v1 is equal to negative root 2 gl, so we can just add it. So we will have v2 is equal to root 2 gl by 3. Okay, so v2, this velocity is root 2 gl by 3, correct? Okay, now we can just substitute it over here and we can get the velocity of v1, right? We can calculate v1 basically. So we'll have root 2 gl by 3 minus v1 is equal to root 2 gl. So from this you can solve it easily. You will get v1 is equal to negative 5 by 3 root 2 gl. So negative sign just tells the direction, so it means that we have assumed the direction as this. So it is correct direction, so it is equal to 5 by 3 root 2 gl, right? So we have found out the velocities just after collision. So first part is done. Now the second part is a bit tricky because in this we have to apply a concept of vertical circular motion. So let's see that. Okay, so let me erase this. So now this is the case which we have to solve, and of course these 2 points are same points, but to represent the things in a clear way, I am just making it distinct. Okay, so you don't get confused, but they are the same points. Okay, so first of all we have to find the length, the height the balls will go. So first of all we will consider this ball. So just notice that it is going in a vertical circular motion, right? So notice that what is its velocity? V2 is equal to root 2 gl by 3, right? And to complete the vertical circular motion, the velocity minimum, what is it? It is equal to root 5 gl, right? Hence this system, I mean this bob or this pendulum basically, it won't complete the circle, right? Hence it will go somewhere over here, I guess. Okay, over here, and then it will start coming back. Okay, so it means that it would have gone to some length L, right? Okay, well, let's assume it as D because we had already assumed L over here, the length. Okay, so by law of conservation of mechanical energy, what we can say is that half into 2m into v2 square, it should be equal to the potential energy at that point 2mg into d, correct? So 2m and 2m gets cancelled, and what is v2 square? It is equal to 2gl by 9 times 2, this half, is equal to gd, right? G and g gets cancelled, so d is equal to 2 and 2 gets cancelled, it is equal to L by 9. So it will go L by 9, okay? Correct. Now what about this? Well, we have to see a bit in this case. Well, first of all, let's bring this inside. So we will get root of 25 by 9 into the quantity 2gl, right? 2gl we will get. So it is equal to root 50 by 9gl, correct? Root 50 by 9gl. Well, is it equal to 5? Well, let's see that. What is 50 by 9? It is 5 point something, right? So notice one thing, that it is greater than the minimum velocity which is required for completion of the circle, of the vertical circle. Hence it means that v1 is greater than v minimum, or root 5gl. Hence it means that it will complete the circle, right? So what will be the maximum height in this case? Well, it will be 2 times the radius. Why? Because it is completing like this. Just a minute. It is doing like this. So this was the pendulum. We have given it a velocity. So it is completing the vertical circle. Hence this L and this L, it can't go beyond that. So in this case the maximum height is 2L, and in this case, in this case it is 2L, and in this case it is L by 9, right? So this is the answer of these two parts. So I hope that you enjoyed this video. If you did, then please do like, share, subscribe this channel, and please support this video. Bye bye, take care, and all the best.